Okay, it's 2:12 now. Alright, so I'm going to display I'm trying to open the file for a moment. It takes a while to buffer. Okay, so wait for a while. All right. So I will the topic on bracketing method will be already finished recording and will be uploaded by uh, for for your for you to follow the lecture on bracketing open method. Okay. Open methods, as the words imply, okay, compared to bracketing. Last lecture I talked about a little bit about bracketing. Bracketing is a technique whereby you bracket the answer and then reduce the length of the bracket so that the root of the equation is trapped within the bracket, and finally we get the root of the equation. Okay, that is the idea of bracketing method. Whereas open method is done without starting without creating any bracket at the beginning. Okay, so you just open it. We assume one number as the root, and then from there we search another number, another root, and finally the correct root will be approached from the process of the calculation. That is the idea of open method. Okay, so ya.
Ada yang tak dapat masuk lagi.
Oh ya, ramai ke tak dapat masuk?
Kejap
Saya hantar link tak? Sekejap saya cuba hantar link.
Mr. K tak boleh try guna kod ke?
Apa dia? Tak dengar, putus-putus.
Mr. K boleh try guna kod, lagi senang student nak masuk.
Macam mana nak dapatkan kod tu? Bukan link tak boleh
Mr.
link?
K, kalau link Mr. K kena approve.
Ya. Yeah.
Kalau Mr. K tak approve, dia orang tak boleh masuk.
Tapi bila dah masuk sekali kan, next time sepatutnya dah tak payah lah.
Dia kalau Mr. Cat dah approve, boleh macam tu. Kalau tak, semua tak boleh masuk kat Mr. Cat. Sebab Mr. Cat yang admin group Teams ni.
Okay, sekejap Saya... Sekejap. Saya rasa hantar link tu sebab itu yang saya boleh buat. Nanti kalau saya kod kat mana nak cari kod tu yang saya tak pasti. Sekejap Tapi itu ramai masuk je. Mungkin masuk lalu kawan ke. Sekejap nak dapatkan kat mana link tu. Kenapa dia buka je. Sekejap Oh, okey. Dia keluar. Okay, minta semua pergi ke link tu itu yang saya boleh buat sekarang ni lah saya akan accept lah. Nanti kod tu nanti tahu nak cari makan masa pula. Okay, so cuba kat link tu nanti saya accept. Baik, Sementara dia orang nak tunggu masuk tu ke proses nak dapatkan semua masuk, saya teruskan dulu lecture saya. Okay, let's continue with my lecture on open method. Meanwhile, I will go ahead and accept these people, everybody. Okay, yang analisis nombor student tu saya dah include, tapi ada yang dia kata does not exist. Mungkin does not exist ni mungkin dia dah ada dalam tapi guna kawan dia punya link. So saya tak boleh nak ni lah. Kalau nak saya type tu, awak keluar dulu, lepas tu saya type, and then awak hantar balik nombor student awak, sebab saya dah tak boleh nak tahu yang mana saya dah type, yang mana saya belum. 169758 Oops. Okey. Sekarang ada berapa orang? Okey, kalau ada yang lalu kawan tu sekarang ni awak keluar dulu, lepas tu awak message saya nombor student. Saya type untuk invitation. Sekarang dalam masa 2 minit. Tapi macam mana dia nak dengar Dia tak masuk lagi. Tapi dia mungkin dia masuk ikut kawan dia lah. Okey. Sekarang ni saya dah cuba type buat semua. Sekarang ada berapa orang? 80 lah. Okey.
Hello, Tuan Karan.
Ya. Sekejap Okey. Okey. So saya sambung semula. Saya punya lecture. Okay, sekejap ada seorang type. A 1700589. Okey, nampaknya ada lagi 16778. Alright. Okey. Terus open method Alright, belum explain lagi ni. Okay, graphical depiction of fundamental difference between bracketing and open. Okay. Alright, so as I explained just now, the bracketing involve the selection of XL, X lower, X upper. And then that is the beginning when we begin our calculation, iteration equals 0. X lower, X upper is a number that we select ourselves. Okay. And then from there, we reduce the bracket. See, getting smaller and smaller. The black dot is the actual answer for the root. Okay. So finally, the root get trapped inside the domain. Whereas open method, you select one initial value xi, and then proceed with the calculation to get the updated value. Okay, and then go to the graph, take another calculation, and then after that, it will, okay, look at here. This one, the root seems to be diverging. Okay, for this one, we initially start at xi, so no bracket involved. Okay, just choose a starting point and then go to the graph, take the gradient, and then settle at another root, better closer to the actual root, which is the black dot there, and then go to the graph and then perform the calculation and so on. So that is the two main difference between bracketing and open method. The first open method that I'm going to explain is called simple fixed point iteration. Okay. Alright, so in this method, let's say we have engineering problem that end up having simultaneous equation like that. Okay, let's say you go do some what we call drawing on shear and moment diagram using equation, because you can sketch shear and moment diagram using area, method of area and things like that. Another method is to write an equation. So let's say you end up with this quadratic equation, and what we are trying to find is the root of the equation, such that the left hand side equals 0. Okay, so what is the value of x that cause the equation to be 0? All right, so how do you do normally to solve that simultaneous equation, the quadratic equation? What method do you apply? You use your calculator, right? Your calculator, key in the coefficient, and the calculator will give you the answer, correct? If you use by hand calculation, formula minus b, x equal minus b plus minus square root of b square minus c equals 0, correct? That is the equation to solve it. Okay, now in this simple fixed point iteration using numerical method, okay, the technique is called simple fixed point iteration. So what you do is you write x in terms of the other variable and numbers. You solve for x here. So x equal, bring the rest to the right. Okay, x equal minus, because there's a negative here, so you bring the two x together, so make it positive on the right hand side. Okay, so 2x equal x squared plus 3. Bring 2 to the left, so you solve for x equal x squared plus 3 divided by 2. If you have a equation such that sin x equals 0, so if you solve for x equal sine inverse of 0, correct? Okay, but we don't do that, because if you write it that technique, then you will get 0. Sine 0 equals 0. Okay, that is called a trivial solution. So from here you can just say x equals 0, such that sine 0 equals 0. Okay, rather than that, we write x, we add x both sides. So x plus sine x equal x, 0 plus x, correct? Like that, okay? We add x both sides. We make a trick in that way, okay? So that's another way of writing x in terms of the rest, okay? So become x plus sine x equal 0 plus sine x, okay? All right. So we write it in this form, xi plus 1 equal gxi, okay? That means, for example, this one, we write xi plus 1 equal xi subscript, x subscript I square plus 3 divided by 2. Here we got x subscript I plus 1 equal sign x subscript I plus x subscript I. Whatever on the right hand side, the subscript will be I plus 1. On the left hand side, the x subscript will be I only. That means you assume one value of x, then you calculate the updated value of x for the left hand side. Okay, that's how you rewrite the equation. Alright, okay, understand? Okay, student A170546 yang WhatsApp ni tak boleh nak key in. Mungkin dia dah ada dalam ni ikut kawan dia punya link kot. Kawan bagi link tak boleh. Kita kena keluar balik. Baru saya boleh type, nanti baru dia jumpa nama tu. Okay, tak apalah. Itu seorang ni tinggal sini. Yang lain dah okay. Baik, proceed with okay. So when you want to calculate the error, epsilon A means relative error. Relative. Okay. Relative means what is the error that incur due to the current value of x compared to the previous calculated value of x. That's called relative. So it's the current x value minus the previous x value divided by the current x times 100. Okay, that is epsilon A. We also have what we call epsilon T and epsilon S, which I'm going to talk about it when we come across the epsilon later. Okay, look at this example. Okay. Solve, use simple fixed point iteration to locate the root of fx equal exponent minus x. Okay. In other words, you want to find x such that epsilon minus x, you get whether you can, from your calculator, you get 0 or not. Right? Let's try an error method. Okay. Now, to apply this, what we call simple fixed point iteration, we have, okay, epsilon minus x equal 0. So if you solve for x, bring x to the left hand side, right? So, because it's negative here, so you bring negative x to the right hand side. So you will get x equal exponent minus x. Okay, this is what the equation is. X equal exponent minus x. Okay, so on the left hand side, the subscript, we change it to I plus 1. I mean, we add the subscript on the left hand side, parameter x to be I plus 1. Whereas on the right hand side, we write the subscript as I only. Okay. All right. So we create a table. All right. Create a table. Okay. And the initial value that has been selected for this problem is x equals 0. Okay. So that is the initial guess. All right. So x subscript 0, that means x of 0 iteration, because the subscript denote number of iteration. So we say x equals 0, x0, that means 0 iteration. That means as a start, we set the root to be 0. Okay. Then with that value of 0, you substitute here. You calculate your, you get your calculator and press it E minus 0. Or in other words, E 0 lah. Minus 0 is 0 lah. So E to the power of 0, what did you get? 1 lah. So you write here 1.0000. So this answer has been written up to 6 decimal places. Okay. Next, with the root that we got, this one 1.000000 root. Okay. We substitute here. Then we press our calculator. You'll get E minus 1.000000. So you will get the answer on the calculator to be 0.367879. Okay. So with the new value of 0.367879, substitute here. So we will get another new value, which is 0.692201 from the calculator. Okay, then this new value you substitute for value of x on the left hand side. Then you get a new x. Okay, and you keep continue doing that until the answer of the two subsequent, so two consecutive, two consequence number, which is one after another, is close enough, like that, 0.57, 0.56, 0.5. So they are close. Okay, so you stop when the answer seems to be converge lah. Okay, converge means is going to the same value or going to the repeat a value which is close enough compared to the previous one lah. Okay, all right, that is clearer, can be seen in terms of the difference between the two consecutive answer by calculating epsilon A, relative error. Okay? How do you calculate relative error? Current minus previous. Of course, the first calculation, we don't have any relative error because we don't have a number before that. Okay, right? So the first line would be blank for epsilon A. Yeah? All right. And then for the first iteration here, okay, the epsilon A is calculated from the current x value minus the previous x value divided by the current x value times 100. Take the absolute value because the answer may end up negative. Error, you can have negative error as well. So you take the absolute value, then it will become positive. Okay. And the answer for the first iteration, the epsilon A will be 100 because 1 minus 0 divided by 1 times 100. Okay, for the second iteration, the error will be the current here minus previous. So you get a negative number, right? Because this is smaller. This is smaller than this one. Okay. So the current minus the previous divided by the current value times 100. Take the absolute value, you get 171.8. So you keep doing that until the data we stop at is achieved. Okay. So you see the relative error is getting smaller. Eventually will be going to 0. Okay. But it's very slow, right? You take how many cycle of iteration for each to get a very small number. It's quite slow and plenty of calculation has to be done. Okay, epsilon t, which is also written in percentage, refer the true error of the root. Okay. So how do you get the true root, the true answer for this equation? E minus x equals 0. Okay. So how to get it? Now you have learned calculus, right? In calculus, you have a lot of technique that has been shown to you, and also a lot of topics that involved in calculus, including natural log, exponent, trigonometry, what else? Hyperbolic function, and a lot of topics that you have learned either in first year at UKM or during your high school, or matriculation or form 6. Okay, so how do you solve E minus x equals 0? Okay, so we write it as E minus x equal x, take ln both sides and do some factoring, and we can get the answer for x. Okay, and that particular technique will give you what is called the true value, okay, of the root. All right, and let's assume that you are able to calculate the true value of the root, okay, which give the answer of 0.5671439. Okay, so the what we call the true error here is calculated by computing the current x minus the exact root of 0.5671439 divide by the exact root of which is 0.4567149, take the absolute value, multiply by 100. Understand? I repeat, 0, the current x value, minus the true value of the root, divide by the true value of the root, time 100. So the first data will give you 100%. Okay, the second one, we get 1.0000 minus 0.56714329 divide by the whole thing, divide by the true answer, which is 0.56714329 multiplied by 100. So you will get 76.3. In other words, to get epsilon t is the current value of the root from the fixed point iteration process. Okay, so the current root true value of the root divide by the exact true value times, sorry, I repeat, the current root gotten from the got from the fixed point iteration calculation. Okay, so we got the root from there minus the exact answer, the true answer, divided by the true answer, time 100. Okay, so that gives you the value in the table of the last column, which is shown there, 100.0, 76.3, 32.1, and so on. All right. All right. The two curve graphical method, example 6.2, separate the equation epsilon minus x equals 0 into two parts and determine its root graphically. So for this particular method, what we do is we write the equation in the form of, so this is the equation in general, f1x equal f2x, correct? So we write one single equation into two equations where y1 equal the quantity on the left hand side, y2 equal the quantity on the right hand side. After that, in order to fulfill the equation of numerical analysis, what we did is we let the quantity on the left hand side to be y1 and the quantity on the right hand side to be y2. What is y1? y1 equal, let's take this, y1 equal xi plus 1. y2 equals epsilon minus x, quantity on the right hand side. So we can just substitute epsilon y equal epsilon minus x, okay? y2 equal epsilon minus x. Starting with the current initial guess of x0 equals 0, so we substitute the information given. So we let y1 equal x, okay, which is the quantity on the left hand side, y equal x, y1 equal x, y2 equal exponent minus x, yeah, y1 equal x, x is being brought to the left hand side, become positive. So positive x equal dashboard again. Yeah, when the times allow you to go home, what you can do is you have the left hand side equal y1, right hand side equal y2. Okay, so we choose a trial value starting from x equals 0. All right, and then we calculate y1 and y2. Okay, we increase the value of x by an increment of 0.2, 0.2, 0.2, 0.2 until 1.0 and look at the pattern of y1. y1 will have what is y1 equal to? Okay, y1 equal x, okay, y2 equal exponent minus x. We want x such that y1 equal y2 lah, correct, to solve the equation. So in these two equation technique, We start, let's say, the initial value that we choose. We need to choose ourselves. So most of the time, 0 is the best to start with. Okay? So start with 0. And if you utilize the simple fixed point iteration just now, you get the new x by substitute the quantity on the right hand side and get the new x of written on the left hand side of the equation, correct? But here it's slightly different. You start with 0 and then you just increase your cell. Okay, quantity equivalent to 0.2. And then fill up the first column of the table. Fill in the table first. 0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, and so on. And then with that first column already fill up or fill in, then you can just calculate using your calculator the value of y1. Or what is y1? Y1 is just equivalent to x lah. So you just repeat, because y1 equivalent to x as shown here, right? Here. So you just repeat whatever x you have on the first column, because y1 equal x, right? Whereas y2, you have to use your calculator to get by punching the number x and then exponent it. Exponent the negative of it. So this is what you get. And then you plot the point on the graph paper like this. Alright, this is the original equation. Fx equal E minus x minus x. Okay? So if the equation is plotted, this is what we shown, and the graph where the line cross the x-axis is called the root, correct? Okay, meanwhile, this equation will produce two graphs, okay? y1 and y2. And these are the set of the plot. One set here. Another set will be this together with this. Okay? So we plot it in a single graph. This is what we got. So wherever the graph cross each other, that is where the root exists for the original equation. And if you draw it on top of each other, okay, so the root of the actual equation, original equation, will be located vertically. If you plot with the same scale, it will be located directly, vertically up of the root. Okay, so you will locate, you will get it vertically up of the root. And if you project further down, where the vertical line intersect the x-axis, will give the root of the original equation. Okay, understand? All right. So that is two equation technique, call it. So the first equation, the first method is simple fixed point iteration. The second method is called two equation graphical method. Okay. The two curve graphical method, we call it. Okay, the following method. Okay, okay, the two equation method, the two curve equation method can be used to illustrate the convergence and divergence of fixed point iteration. Okay, For example, in the equation 6.1, which is y1 equal x, y2 equal gx, these two equations, we can plot it separately. Okay, like that. We plot it separately. Y1, we plot it, but on the same graph. On the same graph, we plot it separately. Okay, these two equations can be plotted separately, as was the case with equation 6.3 and 6.4. The root of fx equals 0 correspond to the abscissa value at the intersection of the two curves. Alright. The function y1 equal x and four different shapes for y2 equal gx are plotted in figure 6.3. Okay. Okay. So the purpose of this graph is to illustrate the case when the solution or the root converge or diverge. Okay. For example, for graph A, initially we assume the root to be x0. So with that value of x0, we substitute into y2, okay, to get the y value of the function for y2. And then go to the next graph of y1 horizontally. We hit the value of x1. With that value of x1 for y1, we go on the graph horizontally until it hit y1 graph, and then go down and so on until we reach the dot. The dot is the root of the original equation. So for this case A, the answer did converge, we call it. Converge means the initial value will approach the root. Okay. However, okay, that same happened as function B, where the original root eventually will go to the root of the original equation. Okay. Contrary to graph C, where the initial value x0 is going away after several iterations, the root, the answer tend to go away from the root. Okay, getting away and further away. So this is a case where the initial value chosen is not good value. And that happened also for case D, where the root diverge. Okay, so the two equation curve can be used to test whether the root, the chosen root of cycle 0 is going to approach the root or otherwise. And these are the computer statement, okay, to find the root using fixed point iteration. All right. So first declare the function or f fixed point. Okay, function. This is typical of MATLAB statement. Function fixpt bracket x0 es is the error to achieve the iteration. We call it epsilon s. Okay, so with this epsilon s, we only see three types of epsilon. Epsilon A, epsilon T, and epsilon s. Imax is the maximum iteration. ITER is the number of iteration, and epsilon A is the relative error. First, we initialize the root to be 0, xr to be x0. Then we ITR equals 0 is to count how many number of iteration will involve. And then we create a do loop, we call it, where the new value of x will be recalculated in a cycle. So whenever we see the do loop, it's always a repetitive type of calculation that constitute a cycle of calculation, a cycle. Keep calculate and calculate and calculate until we instruct the program to stop. Okay, and then bring the answer outside the loop and so on. So that is the do loop. Start with the statement do, end with end do. Okay, when you go outside the loop, then the fixed point solution is the latest value of the root xr. Then we stop the calculation by writing the statement and fixed point. Okay. All right, the second method that I'm going to talk about is called the Newton-Raphson method. Okay, Newton-Raphson method is calculated using a formula. Okay, and the derivation of the formula refer to this diagram here. Okay, refer to this diagram. All right. All right. The curve there, the line curve there, is the equation of the function. Okay. Equation of the function. It's a line curve there. Okay, xi is the initial value of the current iteration, whereas x subscript I plus 1 is the new value or updated value after I plus 1 iteration. Okay, understand? Now, if we project xi to the graph, the dotted line there is the length of fxi minus 0. Okay, so the length correspond to the value of f at computed at xi. All right, so you can draw a tangent graph, a tangent line to the graph at xi, and the slope of that particular tangent line is called f prime xi. Prime here means df dx. Okay, you know the slope is dy dx, right? So dy dx, sometimes we write it as f prime if the function is written in terms of f. F prime means dy dx. Okay, now this particular height from xi to fxi plus 1, if fxi minus 0. Okay, 0 here, the level of the x-axis. And the point, the distance between xi plus 1 and xi, we call it xi plus 1 minus xi. Okay, so if we write this equation f prime x from the definition of derivative, the slope f prime x is equivalent to rise divided by run. Okay, so the slope f prime x here is the rise fxi minus 0 divided by the run xi plus 1 minus xi. Okay, if we rearrange this equation such that we solve for xi and bring it to the right hand side, we solve for the updated value of x or the current value of x equal x subscript I, which is the previous value of x, minus fxi divided by f prime xi. Okay, so this equation is merely derived from this equation by using some manipulation, algebraic manipulation of this equation. And this particular equation, which is boxed and highlighted in black here, is called the Newton-Raphson formula. Okay. All right. Now let's look at an example where we find the root of equation using Newton-Raphson. Okay. Use the Newton-Raphson method to estimate the root of fx equal exponent minus x minus x. The same equation that we were using before. Okay. But now we are applying Newton-Raphson. Okay. Use the Newton-Raphson method to estimate the root of fx equal exponent minus x minus x, employing an initial guess of x0 equal 0. Okay, understand? All right. The first derivative of the function, okay, in Newton-Raphson, what you need to do is you need to differentiate the function, okay, by applying the dy dx that you learned in calculus. Okay, so you apply the equation of dy dx, okay, and you need to differentiate it correctly, especially if it involves like exponent, ln, sine, cosine, tangent. You must remember how to differentiate those type of equation without making any mistake. All right, because if you make mistake, then all the answer that you are going to do will not be correct. Okay, so remember, do some revision how you want to differentiate exponential, natural log, sine. Differentiate sine, you get cos, positive cosine x. If you differentiate cosine x, you get negative sine x. If you differentiate tangent x, you get secant square x. Okay, positive secant square x. Understand? Don't make mistake on that. Okay. Once you make a mistake, you will get a 0 marks. You will get 0 marks. Okay. For all other the rest of the calculation that you write, is just waste of time. Okay. So what is the for answer for f prime x. Okay, f prime x will be equivalent to minus exponent minus x minus 1 here. Okay. So simple a simple differentiation that you make mistake, I can tell you right now, you will get 0 mark. Sorry to say that. Okay. For example, if you differentiate minus x, you write positive x, for example. Then, the table that you create to solve the equation, a lot of time will be wasted lah. Okay. So, I'm sorry to say, it will not be counted at all. Okay. So be careful when you do differentiation. Alright. A1705889. Tak boleh masuk Tapi saya cuba key in, tak jumpa ada dalam team. Mungkin awak masuk guna kawan punya tu, dia dah ada dalam grup lalu kawan, saya tak pasti lah. Saya try juga ni. A1698884. Ada yang boleh, ada yang dia tak jumpa. We couldn't find the student ID matrix. So if you cannot find, then you might have joined it using your friend, your friend ID or something. Okay. Kalau orang lain tak ada masalah lah. Saya try ni. 170413. Tapi takkan awak tak register team kan? Itu macam mustahil pula kan? Jadi saya type, tak keluar. Team tak jumpa awak punya student number. Saya pun tak tahu. Okay, tak apalah. Tak ramai lagi yang masalah ni. Seorang dua je lah. Mungkin InsyaAllah boleh jumpa, masuk juga nanti A1704113 ni penting ni. Sekejap lagi nama dia siapa? EPZ. You ada dalam ni tak? EPZ. Sekejap saya tengok nama dia. Kenapa EPZ ni tak boleh masuk? Nama dia pun tak ada dalam. Pelik. Bila saya search dekat apa ni, dia kata tak jumpa nama awak. Apa masalah? Mungkin dia masuk ikut kawan tak? EPZ ni. Atau dia guna nama samaran lain yang tak ikut alfabet. Jadi saya dah search, tak ada pula EPZ, PZ. Cuba P. PZ. Anyway, tak apalah. Okay, teruskan. Sikit lagi. Alright. Okay, tadi dah I've already explained about the Newton-Raphson formula. Okay. Now after differentiating the function, we apply it to the Newton-Raphson equation here. Xi plus 1 equal xi minus fxi divided f prime xi. Okay. So we will get this one. For this particular function, it has been rewritten in Newton-Raphson formula. Okay, and this is what you get. All right. Okay. Cuma nampak kan dekat skrin saya punya file ni kan? Tak ada yang hilang. Kalau tak nampak cakap yang diam. Okay. So for this open method, as I mentioned just now, we start with initial value of 0. Okay. So the first iteration first iteration initially 0. We start xi with xi equals 0. You can start with any other number. It doesn't have to be 0. Okay. So you can start with minus 1000 or 500. It doesn't matter. But normally we choose 0 because the calculation, if you substitute x equals 0, will be easy, right? All term will be dropped if you start with 0. Okay, so you substitute x equals 0, become e to the power of 0, which is 1 minus 0, divided by minus e to the power of 0, which is minus 1 minus 1. So 1 divided by negative 2. And then from there you minus 0. So 0 minus 1 over 2 become positive 0.5. Okay. And then you calculate the new value of xi plus 1 by substitute the value of x for 0.5 lah. And using your calculator, you will get 0.56633. Okay. And then you keep doing that. Okay. You keep doing the calculation until the difference between the subsequent value is very small. Like that. 0.567, 0.56. That means the solution is about to converge already, right? Okay. About to converge. This is the true error, which can be calculated provided you know the exact answer. And in this particular question, which is the same as before, the exact answer has been given as 0.567. Here, 0.567. 14329. So you can calculate the true error. Yeah, that is by calculating the current minus the true value, divide by the current, divide by the true value, take the absolute value, time 100. So this is the error of each step. And at level of iteration number 4, the error becomes very, very small already. Okay. Understand? Any question?
Mr. Cat.
Yeah.
Dekat XI tu kan, decimal dia memang kena banyak ke?
2, 4, 6, 8, 9 up to 9 decimal places, because if you cut until 4 decimal places, then you can't see the difference between the two. So normally we keep it until 8 or 9 decimal places. Okay? That is normal in numerical analysis and numerical calculation. But the final answer, here they don't give you what is the final answer for the question, right? So the final answer is the last one. So you keep the decimal places until either 8 or 9 decimal places. Okay, follow that shown on the example. Okay. Termination criteria and error estimate. Okay. Now, if you want to calculate the error, this is the formula. I'm not going to go through with you all this derivation, but what you need to know is this one. This is the calculation of the true error formula. All right. Okay. This true error calculation can be carried out if you don't know the true answer. Let's say you are not given the answer of actual value of this one. Zero 0.567149. You don't know the value. So this is the formula that you can use to calculate the true error. All right. This one. Okay. So E error of T means true error for the I plus 1 iteration is approximately equivalent to minus F double prime X root divided by 2 F prime single prime XR multiplied by error square of the true error of the current iteration. Okay, I. Okay, example. Let's calculate the true error of the previous example of this function. So the function. So in order to apply this equation, you need to differentiate the equation twice. So f prime, the first derivative, you get minus e minus x minus 1. Then you take the second derivative, become, this is what commonly students make mistake. Okay, when they take the second derivative, they put some of them maintain the negative sign as negative e minus net x, and then forget to notice that if you differentiate a constant, you get 0. So some of them maintain minus 1 here, things like that. Still put minus 1. Or sometimes, or even most of the time, they mistakenly put negative in the front, things like that. So it doesn't matter how big or how small your error, either you have mistakenly include negative in your derivative, still error. So error, nothing can be done. Okay, that means the rest of your calculation is just wasted. Okay, high probability that you just get 0. Okay, f prime x equivalents to minus e minus x minus 1. That is the first derivative of the function, which can be evaluated at xr equals 0.567149 as f prime evaluate at 0.567149 become negative 1.567149. And then the second derivative we get of x equal e minus x. Okay, differentiate again. This one you differentiate again, you get here and evaluate at 0.567149. Okay, then we'll get 0.567149 as well. Substitute inside the equation. So you got error of t at I plus 1 iteration equal 0.18095 e square ti. From the previous example, the initial error when first iteration is carried out, we get 0.55671439, which can be substituted into the error equation to predict the error of the first iteration, ET1, which is close to the error of 0.671439. And then the subsequent iteration, we got error of 0.0008158, which also compares favorably with the true error of 0.008323, and so on. And for the third iteration, this one, this value is taken from here. Okay, and this one, okay. And for the third iteration, we have 0.606 times of 0.125, which is the error obtained in example 6.3. The error estimate improved in this manner because as we come closer to the root, the x and the psi are better approximated by xr. Okay, and finally, at the fourth iteration, the error is 2.83 times 10 minus 15. This example illustrates that the error of the Neutral-Epstein method for this case is fact roughly proportional by a factor of 0.18095 to the square of the error of the previous iteration. Okay. What are the weaknesses? Pitfall here mean weaknesses of Neutral-Epstein. Okay. So there are some equation where Neutral-Epstein is not performing very well. For example, a slow convergence. That means for you to get the answer, you need a lot of the iteration, many iteration, maybe more than 10 or 20 iteration like that. Example of equation that gives slow convergence is like fx equal x to the power of 10 minus 1. Okay. So if we initially guess x to be 0.5, we write substitute inside the Newton-Raphson equation. So this is the result. And we calculate until infinity even, so many calculations being performed. Then the x value that will be getting is 1.000000. Okay? The true root is actually 1.0000, but to achieve that, you have to go to a infinite number of iteration, so many 1 million iteration, and only you can get the answer. So this is the problem that can be faced using Newton-Raphson if the equation is not suitable for the method. Okay. So this is also a type of equation that can cause Newton-Raphson either to diverge or converge at a very slow rate. For example, if you have the line in the black, the curve in black represent the equation of the function. So we start with x0 here and go to the graph, sketch because the Newton-Raphson utilize the concept of tangent. So it's tangent of the graph. So go to the tangent, hit the x-axis, go back to the graph, sketch the tangent that touch across the x-axis, go vertically to the graph and see. And you can see start from x to the 0, then the root is going away. From x0 to x, the root is here, but the iteration produced x1 here, and then x2, and then it's going away from the root. Okay, this is another. This depend on where you choose. If you face this situation, then try to change your initial value. Okay, and do the calculation again. So hoping that the new value will not cause the iteration to diverge. This is another example where the root is going away from the actual answer, which is here. So start with x0, and then go to the graph, get the tangent, and so on, and can see the tendency of the root to move away from the actual answer. So you change the initial value. Maybe if you're lucky, you can hit the value, choose it here. Then eventually it will converge to the actual root. This is also example where it's happened that the graph, the gradient, the tangent to the graph hit the origin 0. Then you will have problem, because it will maybe end up in the equation where the denominator will be 0 here. But every time you substitute inside the Newton-Raphson equation, there is a division that you need to perform. You divide it. So if turn out that the divide denominator is 0, then it will burst. The calculation will explode, because division of 0 is undefined. This is another example where you get a tangent which is horizontal, parallel to x-axis. Then you will just go to, your calculation will be haywire. Okay, the next method in open method I'm going to talk later is what we call as secant method. Secant method. All right. Okay. This particular test, of course, I'm going to use the online for conducting the test quiz and also the tutorial. Okay, so you need to have the code for the book and the purchase the code lah. I will get the code for you, and everyone will submit based on the question portray online website. Okay, so you need to get the code. The cost to get the code with the ebook together, book will be online also. The hard copy is not available. Okay, you get the online code. And the cost, the price is 87 ringgit. Okay. So the first quiz will be today, pop quiz. The next subsequent quiz and tutorial and homework will be just online. Okay. So you submit based on the time of the given in the website, and then there's a beginning, starting time, and ending time. Most of it, the question for test is multiple choice. Okay, multiple choice question for the quiz, and the tutorial will be some of it fill in the blank, some of it quiz, multiple choice also, and several options available. Okay, so you need to get it, and I will post the what we call this email to you each individually, the code, the password, so that you can key in and log into the website and start the tutorial and also the exam. So for the first quiz, you need to today's quiz will be straightforward quiz. It's just answer a short question, and you need to submit to my email. Okay, this statement type of question. Your email that you need to send is this one. I give you the email address because the previous email is already full. I will WhatsApp to you the email now, and also the question will be WhatsApp to you. Okay. Okay, any question before I send the question for the text? You just answer on a piece of paper. You don't need so many, just half a page to answer the question. And then you take a picture and email to me. Okay. Now I'm going to WhatsApp to you first the email address you should send. And the format will be your name. Okay, I'll write it down here. Followed by your student number. And then quiz number 1. Okay. Or the code, don't forget KKKH3323 quiz number 1. I WhatsApp to you now. They still okay now. Okay. The email address is Kudin. In small letter KUDIN 631 @gmail. And then the format and the title of your email should be your name, followed by student number, then KH3323 quiz pop quiz 1. Pop quiz 1 means quiz 1 lah. That. All right. Ready, everybody? I'm going to upload it now. Okay, and then if you have any question, just use WhatsApp to forward your question to me. Okay? All right, everybody?
Okay, Mr. Cat.
All right. So have a nice day and good luck in your quiz. The time of the quiz is only 15 minutes because it's very short. So within 15 minutes, based on the time of the what we call the WhatsApp email, now it's 3:50. So I give you 10 minutes to 10 minutes to 10 minutes is very long. 5 minutes to take the picture and send. So total will be 20 minutes. Okay. But you actually you can complete it in 5 minutes only. Okay. So 20 minutes. The time shown on the email will be the cut-off point. All right. Good luck and have a nice day.
Thank you, Mr. Cat.
You are welcome. I'm loading the document now. For a while. Okay, bye. This is the question. Assalamualaikum.
Thank you, Mr. Cat.
Welcome.